The chapter elasticity constitutes two lectures. In lecture 1, we are going to study about elasticity and some basic concept of stress and strain, and in chapter 2 or lecture 2 we will study about the different types of modulus and the relation. Now, what do you mean by a rigid body and what do you mean by elasticity? So a body is said to be rigid if the relative position of its constituent particles remain unchanged when external forces are applied to it. That means a rigid body will not change the molecule, or the intermolecular space will not change after applying the force, external force. But if external force, after removing the external force, if the body after changes its position, or the intermolecular particles position changes, or the distance changes, then that property of that body to regain is called the elasticity. So the property of matter by virtue of which a body tends to regain its original shape and size after the removal of the deforming force is called elasticity. Now we will now understand some basic concept before we go deep into elasticity. The first one is deforming force, the force which actually changes the shape, length or dimension of the body. Now elastic body, what is elastic body? The body which perfectly regains its original form on removing the external deforming force. That means when external force is applied, the body changes its shape or the dimension, and then after removing the force, if it regains its original form, then we say it's perfect elastic body. And for what is a plastic body? The body which does not have the property of opposing the deforming force. That means when a force is applied, the dimension, the volume, length might change, and then after removing the force, it does not regain its original shape. Then that is called a plastic body. And how does this body, for an elastic body, how does this, that when an external force is removed, when it is applied, the body changes its dimension. But when it is removed, or how does it regain its shape? It is because of the internal restoring force. So now we come to stress. Stress is basically the restoring force, internal restoring force per unit area. So it is the unit is Newton per meter square and dimension is ml1 t minus 2. Now stress, longitudinal stress is classified into tensile stress, which means that when the force is applied normal to the surface of the body, so it's a longitudinal stress. Now longitudinal stress is further classified into tensile strength. Tensile stress. Tensile stress means that when the force is applied normal to the surface of the body, but the length, there is an, after applying the force, the length increases. That body changes its length. The length increases, then we say that force per unit area is called the tensile stress. And compressive stress, it is when the longitudinal stress, that means force applying normal to the area on the surface, when the length decreases. If a force is applied and the body or that particular body changes its length, but in the reverse direction, that means decrease in length, we say it's a compressive stress. What is volume stress? If a force is applied normal to the surface of the body, but the volume changes, then we say it is a volume stress. What is tangential stress or shear stress? When the stress is tangential or parallel, when the force is applied on parallel to the surface of the body, it is known as the shear stress. And what is the outcome of this shear stress? The shape of the body changes or it gets twisted. So this is the force which is applied on the surface which is parallel to the surface, either this direction or this direction, and the shape, that means the upper plane of this body makes an angle with respect to the lower plane. So that is called the tangential stress or shear stress. Now what is strain? Strain is the change in the size of the body, whether it is length, whether it is volume, or whether it is diameter. The change in the size of the body, that means whether it is the increase in length or decrease in length to the original size of the body, it is called the strain. And that change takes place because of the stress. And strain, both have the same dimension. The change in size, if you consider length, then the length change, that is might be in meter or centimeter, same unit, divided by the original size of the body. If it is in the same unit, and it has to be in the same unit, so the strain is dimensionless quantity. So strain can further be classified into longitudinal strain. That means if you say apply force by hanging few mass, and this, because of this mass you have mg and the force is mg, the weight of this mass, then the force is applied to the surface, and because of this there is change in length. So what is the strain? The strain is the change in length, which is delta L by L, the original length L, capital L. So that is called the longitudinal strain. What is volume strain? Suppose you apply force such that the volume either increases or decreases, then from the original volume the change, either increase or decrease, is denoted as the change is denoted as delta V, and the original volume is V. Their ratio is called the volume strain. What is shear strain? Suppose when a force, external force, is applied to a body parallel to the surface, then its shape changes. The strain produced in this way known as the shear strain. That means the strain produced due to change of the shape of the body. Here what happens? The distance between, here you have the two faces, the lower face and the upper face. Now after applying the force on the surface parallel to the surface, you will find that the upper surface makes an angle phi with the lower surface. And if you take the ratio, that is the shear strain. That means the displacement of the upper surface, that displacement is from A to A dash, which is denoted as small n, and the ratio between the distance of the displacement of the upper surface divided by the distance between the two faces. The distance between the two faces, the upper face and the lower face, is denoted as capital L, which is L by L. And this angle shift is called the tan phi, value is tan phi, which is called the shear strain. Or tan phi, if the phi is very small, we can write down phi is equal to L by capital L. Now what is the relation between angle of twist and angle of shear? Suppose you consider a cylinder where you fix you imagine that you fix the upper surface. You consider the cylinder length as L and the radius of the cylinder is R, and it is fixed at one end. This upper surface is fixed and you twist the lower one. You twist the lower surface such that the angle of shear is denoted as A B A dash. This is the shear, that is denoted as phi. And what is the angle of twist? It is A O A dash, that is denoted as theta. And what is their relation? If you just calculate the arc of A dash, then we get L theta, and if you calculate the arc of A dash in terms of phi, you get L phi and R theta. And if you equate them, you get phi is equal to R theta by L, where theta is the angle of twist and phi is the angle of shear. Now, Hooke's law. What does Hooke's law states? That if you take the concept of stress, which is force per unit area, and strain, that is the change in the shape or the volume or the dimension of the body to the original dimension of the body, then within elastic limit, stress is proportional to strain. Which here we can write that stress by strain is equal to constant, and this is Hooke's law. So this constant is known as coefficient of elasticity. This constant is also known as modulus of elasticity. Now the modulus of elasticity depends only on the type of material used. That means if it is different for steel, it is different for rubber. It does not depend upon the value of the shear and strain. So whatever you give the stress, you get the strain, but the ratio is constant. So their constant value will have a particular value for a particular material. So here we come to the conclusion of lecture 1. Thank you so much.